Hello and welcome to our first lesson about simple harmonic motion. What I want to do in this lesson is just give you a quick overview of some terminology that we'll use in this unit related to pendulums and other things, and a bigger scope of a picture about what this idea of motion is. In science, we call the back and forth motion of a pendulum simple harmonic motion because it repeats in a predictable way. Now, there's a lot of things that exhibit this, but a pendulum is probably a really easy example. So when we talk about simple harmonic motion, there might be some words that jump in your mind, like it's bouncy, a bobblehead goes back and forth. Maybe there's a certain frequency that a bobblehead might bounce back and forth at. If it's really on the end of a spring, it will be an example of simple harmonic motion because of its regular intervals as it goes back and forth on top of that toy. So what are some properties of simple harmonic motion? Well, one is that we can really measure quantifiable things like the period and the frequency. The period is the time it takes to complete one cycle. So we use the symbol T, and the unit is a unit of time because we're actually measuring the time from beginning to end, or the time it takes to repeat that cycle. And this unit is measured in seconds. Frequency is the number of cycles per unit time. So a cycle, a frequency is actually the inverse of the period and 1 over the seconds. Now that unit gets a special name and is called a hertz. You might have heard that when you talk about frequencies on radio or stations like that where you're talking about so many hertz. That's the idea of the frequency of the waves and a way of measuring those. So frequency, as I mentioned before, is related to period. The frequency is the inverse of the period, or 1 over the period. So if you know one quantity, you know the other just by taking the inverse of the opposite quantity. All right, so let's say we're going to do a couple calculations, right? You're on the beach and your feet is in the water and you notice that there's a new wave that crashes on the shore every 4 seconds. We want to find the frequency of that wave. This might be a little bit of a review from some earlier science classes, but I want to make sure we have this foundational things and we're ready to go into more future things. So to find the frequency, remember the period is 4 seconds because that's how long it takes between waves. That's the time between the waves. The frequency would be the inverse, or 1 over 4, 0.25 hertz in decimal form. Another one is we might be talking about a tempo of a song, right? So a Taylor Swift song has a tempo of 160 beats per minute. How many seconds are in between each beat? So in other words, how long does it take for the beat to happen in between those, right? So if the frequency is 2.67 hertz, we can take the reciprocal of that, and it's about 0.37 seconds of time. All right. Where did the beats per minute come from? Well, when we talk about that 160 beats per minute, we know that that's happening every minute. We want to convert that to seconds. So we can use a little bit of dimensional analysis where we know we want, instead of beats per minute, we want beats per second. So I'm going to set minutes up to cancel, and therefore I'm taking 160 divided by 60. That's where the 2.67 hertz comes from. All right, so what you're going to do is you're going to use some of these things to help you understand your project in the end. So remember this idea of calculating the beats, maybe come back to this idea of taking the beats per minute divided by this number of seconds in a minute so you can figure out that period. That's what you're going to be looking to do for your final project, your Beats by project at the end. Thank you and have a great day.